This video considers the topic of the systematic nomenclature of the alkanes, or to put it in slightly more everyday English, how to name alkane molecules using a system of rules that chemists have agreed on. By the end of the video you should be able to produce the systematic name for a straight chain or branched alkane using this system of rules. We'll use a simple example to introduce the rules involved in naming alkanes. Here's a 2-carbon alkane, and the systematic name for it is ethane. You might be familiar with that already from school studies. We can unpack this name to show the rules involved. And at the end of the name we find the letters A, N, E, and that's the same for all alkanes. So whenever you're naming an alkane, the name will end with the letters A, N, E. The start of the name shows the number of carbons involved in the chain of the molecule. In this case 2 carbons, and so it's the letters ETH, eth, so ethane, putting it all together. You do need to be able to recall from memory these prefixes, the thing that tells you the number of carbons in the chain, up to 10, and so there they are for you to take note of. We'll look at a few examples to illustrate this system, and if you're feeling confident about it, you might want to pause the video in each case and work the name out for yourself. So looking at this first one, it's drawn in the shortened structural format, but you could tell it's an alkane because the number of hydrogens on each carbon says there's no double bonds present between the carbons, and there's certainly no other elements present. It's got 4 carbons, so the name is going to start with BUT, bute, the prefix for 4 carbons, and then always the ane ending. Next one, drawn in the skeletal format. If you count the carbons, there's 8, and so that's the oct prefix and then the ane ending. And then thirdly, let's work backwards from the name. So the name hexane, what would be the structure of that molecule? And the hex tells you there's 6 carbons, and the ane ending tells you it's an alkane. So full structurally it would look like this, skeletally like that, and shortened structurally, well, if you really condense it down, you'd summarise the 4 CH2 groups in the middle, you can write it like that. Well, hopefully that makes naming alkanes look quite simple, but there's a bit of complexity introduced when we consider the fact that alkanes can have branches of carbons coming off the chain. So we need to extend the rules to be able to name branched alkanes, and we'll introduce this as a series of steps. So here's an example that we'll be using to introduce this system, and the first step is to find the longest continuous chain of carbons in the molecule. When we say continuous, that means that you could sort of trace the chain with your pen without taking the pen off the page. And a very important point to note here is you're not just looking for a straight horizontal chain as the longest chain, but chains can bend and twist and go around corners. In this case, if we mark out the carbons highlighted in yellow, we find that there is 8 carbons in the longest chain. So you can see at the right hand end there, there's a little trap that you could just continue the zigzag along, but that would only give you 7 carbons, and instead the longest chain is found by heading down. Now, once we've identified the number of carbons in the longest chain, we name that as if it was an alkane, and so the main part of the name of this alkane will be octane, the name for an 8-carbon alkane. Step 2 in naming a branched alkane is to identify the branches that stick off the main chain. So in this case, I've highlighted them in blue there. It's important to note that the branch is not considered to include the carbon that is in the main chain. So it's only the carbons highlighted in blue that are considered to be part of the branches off this octane chain. Now once we've identified them, we can name them for the number of carbons they contain. And the system is shown here. Note that the prefix, meth, eth, prop, and so on, follows the system you already know for number of carbons, but instead of an ANE ending for an alkane, branches have a YL ending. So a 1-carbon branch is a methyl branch, a 2-carbon branch is an ethyl branch. So following that system, if you happened to have a huge molecule with an 8-carbon branch, that would be an octyl branch. So we'll just tag the branches with their names, and the one ringed in red there is 1 carbon, so that's a methyl branch. Next one ringed in red is also 1 carbon, so that's a methyl branch. And the final branch, 2 carbons, so that's an ethyl branch. The next step is to give each branch a number to show its position along the chain. So we're going to number our 8-carbon chain, the longest chain, and use that to show the position of the branches in the name. But an important point here is that we're not just necessarily going to count from the left-hand end of the molecule, because, of course, a molecule is just an object. You can pick it up, turn it round. There's no reason we should have drawn it this way. We could easily have drawn it flipped over on the page. And so the rule here is that you count from whichever end of the molecule gives you the smaller numbers for the branches. And it's actually quite subtle in this case. It turns out that you'll need to number from the right-hand end of the octane chain, because if you do this, you've got a branch on carbon 3 and then 2 branches on carbon 5. And if you add those up, a 3, a 5 and a 5 makes 13. If you numbered the other way, it would give you 2 branches on carbon 4. So if you numbered from the left, you get 2 branches on number 4 and 1 on carbon number 6. And 4 plus 6 actually adds up to 14, which is just slightly higher than the 13. So we're going to number from the right-hand end of the molecule in this case. And so we have a methyl branch attached to carbon 3, and then a methyl and an ethyl attached to carbon 5 of the chain. So how do we actually show in the name which carbon the branch is attached to? The next step is that you put the number of the carbon the branch is attached to in front of the branch's name. Let's look at that in practice. So with the methyl group attached to carbon 3, we write 3-methyl to show that it's a 1-carbon chain, 1-carbon branch attached to carbon 3 of the longest chain. Then moving along, we've got a methyl attached to carbon 5, so we put 5-methyl to show that's a 1-carbon branch, a methyl branch attached to carbon 5 of our longest chain. And likewise, we write 5-ethyl for that 2-carbon branch attached to carbon 5. So we finally reached the stage we can start putting the name together. And so the next step is that you put the branches in front of the name of the longest chain. So all these numbers and branch names we're going to put in front of the octane that we decided as the longest chain in the molecule. And there's a rule here that you write them in alphabetical order. So ethyl, beginning with E, is going to come before methyl, beginning with M in the name. And when we write that, it looks like this, quite long. But that's part of the fun of naming these molecules. So we've got the 5-ethyl, and then the 3-methyl and the 5-methyl, and then the octane. Note that you always have a hyphen between a letter and a number in these names. We're not quite done in this case. The final step is that you summarize any branches of the same type using prefixes like di, tri, tetra, etc. So in this case we've got 2 methyl branches in the molecule, and so we're actually going to shrink the name down slightly by putting those 2 methyl branches together in the name, as shown here. So instead of 3-methyl, 5-methyl, we can write 3,5 dimethyl. And so to a chemist that tells you that along this octane chain there are 2 methyl branches. One of them is on carbon 3 and one of them is on carbon 5. There's only the 1 ethyl group, so we leave that unchanged. Just note carefully here that the use of the di in front of the methyl does not change the alphabetical ordering. So despite the fact that D comes before E in the alphabet, we leave the methyl groups listed after the ethyl groups in the name because we ignore the di bit. So E for ethyl still comes before M for methyl. Do note here a couple of things. One is that where you write numbers next to each other, like the 3,5 dimethyl, you put a comma between them to show that it's two separate numbers, not 35. And also you need a number for every single branch. So even if those two methyl branches were on the same carbon, for instance they were both on carbon 3, you can't just write 3-dimethyl. There's two methyl branches, you need a number for both of them. In that case you'd have to write 3,3-dimethyl. So many steps involved. Will probably seem a little bit unfamiliar and scary at first, but you'll soon get the hang of it and find naming these molecules quite entertaining. I'm sure you're eager for a chance to have a go at using these rules, so you're going to see a few examples of molecules, and you can use the system to produce their systematic names. Pause the video, have a go at this first one. So hopefully you spotted that it's not a 6-carbon chain with a 2-carbon branch, but actually the longest chain dips down at the right-hand end there to make a 7-carbon chain, heptane, and then there's a 1-carbon branch on carbon 3 if you count from the right to give the lowest possible number. So 3-methyl heptane. Here's another one for you. Pause the video and have a go. So this time the longest chain is 6 carbons, and if we count from the right again, they're both the branches are on carbon 3. They're 1-carbon branches, so 3,3 dimethyl hexane. Here's an even more entertaining example. Pause the video and have a go at naming it. So the name is this. Hopefully you spotted that the longest chain is an 8-carbon chain. I've highlighted it in red for you there. And so that gives us 2 methyl groups, one on carbon 2, one on carbon 6. Again, we've got to count from the right to get the lowest numbers. And a 2-carbon branch, an ethyl branch on carbon 4. This time, have a go at drawing the molecule from the name. Use the skeletal structural formula system to draw it. So pentane tells us there's a 5-carbon chain. That's going to be an M or a W if you drew it the other way up as a zigzag. And then we can put a 1-carbon branch on carbon 2 and 2 1-carbon branches on carbon 3. Final couple of examples for you to have a go at. First of all, a challenge to draw 3-ethyl 2-methyl pentane as a shortened structure. And that'll come out as follows. Note that where you've got a branch along a chain, you put it in brackets, and you can kind of summarize the carbons and hydrogens involved. So with a methyl group on carbon 2, that second carbon along, instead of having 2 hydrogens attached, and being CH2, it just has 1, so we write CH, and then brackets CH3 for the methyl group. And then the third carbon along, where we've got the ethyl group, again we've only got 1 hydrogen directly attached to it, so CH, and then the ethyl branch has 2 carbons and 5 hydrogens involved, so we can write C2H5, and then the remaining carbons of the pentane chain just as normal. A final test. Here's the name, here's a structure drawn in the shortened structural formula, so think about what we've just said about how branches are represented. What would be the systematic name for this molecule? And it turns out to be 2,2-dimethyl pentane. So if you count the carbons in the main chain, there's 5 of them, hence the pentane, and we've got 2 CH3 groups attached to the same carbon, which, if you count sort of from the right-hand end as it's written here, would be carbon 2.